Particle physics is a branch of physics that focuses on the study of the fundamental building blocks of the universe and the forces that govern their behavior. It seeks to understand the smallest, most elementary constituents of matter and the fundamental forces that act upon them. This field has made significant strides in our understanding of the universe's fundamental nature and has led to the development of the Standard Model, which is the current theoretical framework describing particle physics. In this detailed overview, we'll explore the key concepts, particles, and theories in particle physics. Elementary particles. At the heart of particle physics are elementary particles, which are the smallest units of matter and energy. These particles can be classified into two main categories. Fermions, these are particles that make up matter. They include quarks, up, down, strange, charm, bottom, and top, and leptons, electron, muon, tau, and their associated neutrinos. Quarks combine to form protons, neutrons, and other hadrons, while leptons include electrons that orbit atomic nuclei. Bosons, these particles mediate fundamental forces in the universe. The most well-known boson is the photon, which mediates the electromagnetic force. Other bosons include the W and Z bosons, responsible for weak nuclear force, and gluons, responsible for the strong nuclear force. Fundamental forces. Particle physics also seeks to understand the fundamental forces that govern the interactions between particles. These forces are gravity. Although gravity is the weakest force, it is responsible for the large-scale structure of the universe. In particle physics, gravity is typically not included in the Standard Model. Electromagnetic force, mediated by photons, this force governs the interactions between charged particles and is responsible for electricity and magnetism. Weak nuclear force, the weak force is responsible for processes like beta decay in atomic nuclei. It is mediated by W and Z bosons. Strong nuclear force, this is the strongest force, binding quarks together to form hadrons, like protons and neutrons. It is mediated by gluons. The Standard Model. The Standard Model of particle physics is the prevailing theoretical framework that describes the interactions between elementary particles and the forces that govern them. Successfully explains electromagnetic, weak, and strong forces, making it a cornerstone of modern physics. However, the Standard Model has limitations, such as not incorporating gravity and not explaining the nature of dark matter and dark energy, which make up a significant portion of the universe's mass and energy. Particle accelerators. Particle physicists rely on particle accelerators to study elementary particles. These machines accelerate particles to nearly the speed of light and then collide them, allowing scientists to probe the fundamental particles and forces at extremely high energies. Prominent particle accelerators include the Large Hadron Collider, LHC, at CERN and the Fermilab Tevatron. Beyond the Standard Model. While the Standard Model has been incredibly successful in explaining many phenomena, it is not a complete theory. Particle physicists are actively searching for extensions or modifications to the Standard Model to address its limitations and mysteries, such as dark matter, dark energy, and the hierarchy problem. One prominent candidate for extending the Standard Model is string theory, which posits that particles are tiny vibrating strings, and it attempts to unify all fundamental forces into a single framework. Supersymmetry is another theory that postulates the existence of new particles, providing a potential solution to several issues in the Standard Model. In conclusion, particle physics is a fascinating field that delves into the fundamental constituents of the universe and the forces that govern their behavior. While the Standard Model has been a remarkable achievement, the search for a more comprehensive theory continues, and it remains one of the most dynamic and challenging areas of scientific research.